Hi, welcome to Shiko Practicing Math Lab, Learning through Practicing. Okay, so today's in this video, we're going to do the sequence and the series practice number 2 here. So in this practice exercise, we're going to take a look for a given sequence and whether this sequence is a convergent or diverges here. And if the sequence is convergent, then what is the limit for these convergent sequences here? Okay, so let's take a look. Here are the 12 problems we're going to work today. And probably we won't be able to finish in one video, so maybe we will break into 2 videos here. Just like we did for the previous video, now is a good time to pause your video and get a pen and paper and try to work these 12 problems first. Then after you finished, then resume the video and so you can check your answers to see whether your answers match my answers, okay? And so now is a good time to pause your video and I'm going to go to the whiteboard and to show you, okay? Okay, welcome back to the whiteboard. I hope you got a chance to finish all the 12 problems for here. So let's start. Like I always mention at the beginning of each video, the problems I arranged is from the easiest one and getting harder and harder here, right? So let's start the one. So for the ANs here, for the part A, if a given series or given sequence, the general term, this is 3 plus 5n squared and n plus n squared. So I want to see this sequence is a convergent or is a divergent sequence. So the way we defined is a convergent or divergence here, right? So let's do a quick kind of review and to see you remember. If it's a convergent, right? So that means if you let the n approach to infinity, your an going to approach to some fixed numbers here. It's L. So here could be a negative number, positive number, but it has to be, approach to a fixed numbers here. Okay. So the first ones here. So let's see here is like a limit n approach to infinity. The an that means is a limit n approach to infinity and the 3 plus 5n squared and n plus n squared. So in order to find the limit for these ones here, and what we can do is we can divide by the highest terms here, right? So here, this is n squared, and this is n squared. So we say, okay, let's divide it to see what we have here. So then if you divide by n squared, so this will be n over n squared plus 1. Then this is the 3n squared plus 5, right? Okay, so these ones here, if you simplify a little bit, so this is n approach to the infinity. So this is 1 over n plus 1. Then this is 3 over n squared plus 5. So when you let the n approach to infinity, I know this term going to approach to zeros, correct? And this term also is going to approach to 0. So the whole thing here is going to approach to what? Approach to 5 as the n approach to infinity here, right? So you're going to 5 as n approach to infinity here. So we know this one is a convergent sequences, right? So it's a convergent, and what is the value it converges to? It converges to 5 here. It's pretty straightforward. Okay, now let's take a look at part B here. The part B, the general term was defined as an equal to the 2 plus pointer a6 to the nth power. Okay, so the same way we say, okay, let's limit n approach to infinity. The an is equal to limit n approach to infinity 2 plus pointer a6 to the nth power, right? Okay, so when you do the limit to the 2, because the 2 is by itself, has nothing to do with n, so when you take a limit or not, it doesn't matter. So the 2 come out here, right? Then it will be 2 plus limit n approach to infinity. Then this is point a6 to the nth power. And then I know these terms here will approach to what? Will approach to zeros here, right? Why? It's because, okay, so let's try to do another review. So we know the limit n approach to infinity, so to the r to the nth power, okay, going to approach to 0 if r is between the -1 to 1. This is what we learned, when we talk about the, the geometric, like the numbers. So that means this one's here, write better. So this is n, so it's approach to zeros, right? So that's why this one is approach to 0. So this one is 2. So as the n approach to infinity. So what happened? This one is a convergent sequence also. What is the value it converging to? It converging to 2. All right, so this is pretty straightforward. Okay, so part C is very similar. So if an is equal to the 3, the square root of the n, and this is the square root of the n plus 2. So because they both have square roots of the n, square roots of the n, so what I can do, I can divide by the square roots of the n, both on the numerator and the denominator. So this is square roots of the n, I divided by the square roots of the n. Then this is the square roots of the n, I divided by the square roots of n plus 2 over the square roots of the n's here, right? Then the limit n approach to infinity an is equal to your limit n approach to infinity, this number, and let's simplify it a little bit. So square roots of n cancel, square roots of n cancel. So the top going to be 3, and this is 1 over 2, the square roots of n. So I know when the n approach to infinity, that means these numbers here, the denominator going to get bigger and bigger, right? So what happens when the denominator get bigger and bigger will be equal to zeros here, right? So that's why, what is this number going to approach to here? Going to approach to 3, right? So that's why, so for this ones here, this one is also is a convergent sequence. And what is the number it converging to? It's converging to 3 here, okay? Now, let's take a look at part D here, right? Let's say part D here. I'm going to erase here so I can have more space to write. Okay, so part D here, this one's here is an is equal to 4 to the n, 1 plus 9n, see here. Okay, so for these ones here, I'm going to find the limit an approach to infinity, an is equal to the limit n approach to infinity. Then I'm going to do a little bit because the largest ones here is 9n's here, right? So I'm going to divide by the 9n on the both numerator and the denominator. So the denominator, so this is 9n for the 1 plus 9n to the 9n's. And the top here will be 4n to the 9n. So then this will be the limit n approach to infinity here, right? So in here, the top, if you take a look at the top, this is a 4/9. I can factor the n out, right? So I can say this is a 4/9 to the nth power. And then here you have 1/9n. And what happened to the 9n over 9n's here? The 9n over 9n's, they cancel out, will be 1s, right? Okay, so now let's take a look when the n approach to infinities here. So when n approach to infinity, so we know what happened to this number. This is 1/9. 9 to the nth power going to go to infinity. So the denominator becomes bigger and bigger. So the whole thing will become to zeros, right? So this one approach to 0. So here, then take a look at the top here. This is a 4/9 to the nth power. So it's the same thing because r, remember the review since I just put here, r is equal to 4/9. Because the r is less than 1, so r to the nth power will approach to 0. So I know my top here going to approach to 0 as well. So what happens here? So here is limit n approach to infinities here. And so this is the 0, and this is the 0 plus 1s here, right? So this is 0 plus 1. So this will be equal to the 0 over the 1, so equal to 0. So I know what happens here. This is a convergence also. And what is the value it converging to? It converging to 0. Okay, so very good. Let's take a look at part E here. And let me erase here. Okay, so part E here. Okay, so the part E I'm talking about is the cosine functions here. So ANs here, this is a cosine n pi over n plus 1. Okay, so now I'm doing the limit n approach to infinity an. So it's the same thing, like I take the n infinity cosine n pi over n plus 1. Okay, so let's take a look at what happens inside here, right? So the n over n plus 1, let's move that one out. So this is basically we are looking for n approach to infinity, n over the n plus 1. So we said you can divide n on the both numerator and the denominators here, right? So this is over n, 1 over n. So this one will give you limit n approach to infinity. And then what happens here? So this is 1, and this is 1 plus 1 over n. So when the approach to infinity, this one becomes to zeros, right? Okay, so this one become to 0. So the whole thing is going to become to what? Become to 1. So now I can bring this one down. So I will say, okay, so the limit n approach to infinity cosine n pi over n plus 1 pi, n plus 1. This one will be approach to cosine what? Cosine pi here, right? So what is the cosine pi? Cosine pi is equal to what? Cosine pi will be equal to -1s, right? So I know this one is a convergent. And what is the value it converging to? It converging to the -1s here, okay? So now let's try to do one more problem. Maybe it will be a good place to stop. And then the second one, we're going to continue the next 6 problems so we don't overload you with like so many problems and so long, you'll be tired of watching the videos here. Okay, so let's take a look at F here. Okay, so the F here, I tell you the AN is equal to 2n minus 1, the factorial, and this is a 2n plus 1, the factorial. Okay, the reason why I put here, because you're going to use the factorial effect a lot later when we're dealing with the series here, right? So here, let me take it. So let's see here. So I'm still find the n approach to infinity, an, right? So that means the n approach to infinity, 2n minus 1 to the factorial, then this is 2n plus 1 to the factorials, right? So I'm going to write in here a brief review about the factorial. Factorial have such good characteristics, right? So we know the n factorial, you can write as the n times what? N minus 1 factorials, right? So that's the fact. So if you don't remember, so for examples here, right? Let me give you a simple example. So I know the 6 factorials, right? So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, right? So now if you take a look at 5 times 4 times 3 times 2 times 5, what is this? This is 5 factorials, right? So that's why the 6 factorial you can write as 6 times 5 factorial. So this formula here, we are going to use it very, very much later when we try to test the series here, right? Okay, now let's take a look. How do we use these ones here? So these ones here, so I'm going to say this is a limit n approach to infinity. The top here, this is 2n minus 1 factorial. Okay, so I'm going to break the 2n plus 1 factorials here. I put it in here. So 2n plus 1 factorial, based on what the formula I just tell you, what is going to be equal to, will be equal to 2n plus 1 times what? This one minus 1, so will be the 2n factorial, right? Then I can break it down again. So I can use the property to do the 2n's again, right? So I will have this is a 2n plus 1, then times the 2n factorial. I can use the formula here. So this will give you the 2n. So what is the next one here? Will be the minus 1's, right? So it's a 2n minus 1 factorial. The reason why I want to break it, because did you see here? On your numerator, you have a 2n minus 1 factorial. So that's why I hope I can cancel. So this will be the 2n plus 1. And this is a 2n. And what is here? This is a 2n minus 1, the factorials, right? And now you can see here, you say, okay, so the 2n minus 1 factorial and the 2n minus 1 factorial, you can cancel. So that's why you will get the limit n approach to infinity. So this is a 2n plus 1 and 2n. So what happens here? The bottom going to approach to what? Because this one going to approach to infinity. And your numerator is 1. So when the denominator going to become very, very large, what is here? So this one approach to 0. So for this sequences here, this is a convergence sequence also. And what is the value it convergent to? Converge to 0. Okay, so now I think it's a good place to stop. And we did 6 problems for this video. So we're going to continue the remaining 6 problems. It will be a little harder, and we're going to introduce the different technique to find the, the limit to decide is converging or not. Okay, so right now I'm going to stop here, and so we're going to do the next 6 problems in the next videos here. Okay, So don't forget, practice, 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 right? That's the way to be successful in math. Okay, talk to you later.